Okay. In preparation for the exam on Monday, told you guys I would go through the practice here, so I missed this one, it's a form. So this is practice test 2B, problem 1, and this asks you to use nodal analysis to find V1, V2, and IO. Okay, so just real quick, you have V1 is right here, okay, and you get V2 here, and then IO right there. And so if you write the proper equations, you're going to write a Kirchhoff's current law equation at each of these. So you start with V1, and with V1 we do everything, I always do everything out, right, out, out. And again, it doesn't matter, you can do in equals out or all in or whatever, but you basically say, okay, I need the voltage across this 2 ohm resistor, so that's going to be the difference in voltage across it is going to be V1 minus V2, the plus side minus the minus side, divided by the resistor, right? So that gives you volts over ohms, that gives you amps, right? Because we're writing a current equation. Likewise, if we look here, this is IO, okay? And one of the things we need to solve for, but V1 is on this side. The voltage here, if this is the ground, this is 0 volts, then this has to be 8 more than 0 volts, so that has to be 8 volts. So I could say that this path through the middle is going to be, the difference across that resistor will be V1 minus 8 volts divided by 1 ohm. Okay, so again, you're doing volts over ohms to get amps. Going down, I didn't label that resistor, it's a 2. But going down, plus to minus, you're going from V1 to the ground. So you have plus V1 minus the ground voltage, which is 0 over 2, is equal to 0. And that would be your first equation. Okay. Second equation, KCL at the voltage node over here, V2. All right, if we look in down, we have V2 to the ground over 4, plus up this way is going to be V2 minus V1 over 2. And then finally, the current here is actually set by this current source. So you can either say that minus 4 amps goes out of that node, right? Because if I'm writing everything out, I could say that if 4 comes in, minus 4 goes out. Or, if you don't like that, you can just say that this is out, this is out, so it has to equal in, and in would be 4. So that's fine too. Okay. At this point, you have 2 equations, 2 unknowns, and so you can solve it by whatever means you guys want to use to solve matrix operations, substitutions, things like that. Just to get it set up, right? If this is equation 1 and this is equation 2, if I take equation 1, I can factor the V1 out, and I can get V1 times 1 over 2 plus 1 over 1 plus 1 over 2. I then have, this is V2 over 2, so I have minus V2 over 2, and then I have this minus 8, so I move that to the other side, minus 8 over 1. Like that. That's my first equation. Second equation, okay, is going to be, I can factor out the V2, so I get V2 times 1 over 4 plus 1 over 2 minus V1 over 2 is equal to 4. Now, I looked at the solutions, and while this is correct, you might want to reorganize, like for some of the problems that it just asks for equations, you might want to reorganize these so that they're in basically like in matrix form. So you might just want to rewrite problem 2, not for this one necessarily because it asks for an actual solution, but when it just asks for equations, you probably want to combine these numbers, okay, and you probably want to have something times V1 plus something times V2 equals something. You want to try to get everything in that form, like you were about, even if you're not going to do a matrix operation, maybe just so that you can straighten that out, just because that's the way she presented all her answers on the practice. Okay, so real quick, this is a half plus, sorry about that. This is, I just want a point. Pointer, there we go. This is that's not working. Okay. Sorry. That's a half plus 1 plus another half, so that's 2. So I could say that this is 2v1 minus 1 half v2 is equal to 8. If you want, you can multiply everything by 2 if you don't like fractions and say 4v1 minus v2 is 16. And then this equation is, this is 3 quarters, right? 3 quarters in here. So I'm going to multiply everything by 4, and so I get minus 2v1 plus 3v2 is also equal to 16. Okay. Now, so these are my two equations, right? I need to solve these for v1 and v2. One thing you do not want to do is say, oh look, they're both 16, set them equal. That's not good, right? Because you're going to end up with two variables in one equation. So just be careful with the way you do this, right? You know, you could do the thing where you multiply this by 2 and add them together. Now cancel out the v1s if you want. That's one way to do this. You're not always going to be able to do that though. So typically what I do is I'll solve one of the equations for one and substitute in the other. So in this case, I would say from equation 1, I have v2, I'll move that to the other side, and I move the 16 back over here. v2 is equal to 4v1 minus 16, and then I would take that and stick it into equation 2 and say that minus 2v1 plus 12v1 minus 48 is equal to 16. That gives me 10v1 is equal to 64, and v1 is equal to 6.4 volts. I don't even know if that's right. I don't have a calculator with me for some reason. I really want to know, my son likes to play with it, and I can't find it. Anyway, so you guys can verify the math. She has solutions on there anyway. But once you have this, you can then say v2 would be equal to, you have this equation right here, it would be 4 times 6.4 minus 16, whatever that is. And then finally, the last thing you need to do is you need to solve for I/O, right? So I/O is the current here through this resistor, so it's going to be plus to minus. The voltage you have there is going to be V1 minus 8. So this is something we could have written at the very beginning, just to have down. And I definitely write this down if you want partial credit, but I/O is equal to V1 minus 8 over 1. And so you can plug in your V1 and solve for what that is. All right, so that's kind of I went through that pretty thoroughly. I'll probably try not to go into as much detail on the subsequent ones, but that's how you would approach a no-wall analysis problem. Okay. Problem 2, this is still practice test 2B, is a mesh problem. Okay. We got the 3, 2, and then a dependent source. We all know how much you guys love dependent sources. Minus at the top, valued at 3 times Vx. I have a resistor here, and then a 10 ohm, plus on the right, 10 volt, excuse me. And then below, got 2 and a 4 volt, and then a 2 here. Okay, 2, 2, 4. Now, you'll notice this is 3Vx. We need to know what Vx is. Vx is given from plus to minus is the voltage here. You're also given mesh currents, I1 and I2. And this problem states to write the two mesh analysis equations. So you don't actually have to solve for I1 and I2. Now, you will need a third equation because of the dependent source. So the first thing you want to do, right, once you already have your meshes established, is you want to write what Vx is in terms of I1 and I2. So if you look down here, Vx is the voltage from plus to minus. So I2 is going the right way and I1 is going the wrong way. And if you combine those, you could say that Vx is equal to the 4 ohms that I have in that resistance times the current, which is going to be I2, which goes the right way, minus I1, which is going back the other way. So you can rewrite this as 12 times I2 minus I1. Okay? And that way you don't have to include Vx in any of your equations, because when you write your equations, you want to make sure that the only equations you have the only variables you have are I1 and I2. Okay. All right, so you're going to do KVLs for 1 and KVL for 2. There's no current sources, so I don't have to worry about super meshes. I'm going to go around this way, plus to minus, like this. I'm actually going to go the opposite way here, plus to minus. So as I go around this way, I go into the plus of this 3, and I write 3 times I1, and I1 is the only current in this 3 ohm resistor. I get to the top, okay, I have plus 2, and again, I1 is the only current there. I then get to the minus side of this. This is a voltage source, so I simply write the value of the voltage, minus 12 times I2 minus I1. Come around, I get to the plus side of this 10 volt, plus 10, and then finally, you can write this as plus 4 times I1 minus I2. You could also write it as minus Vx. If you write it as minus Vx, that's fine, because you'll see that if you write minus Vx, you just get the opposite of what I wrote, and then equals 0. At this point, you just want to kind of clean everything up and get all your like terms together. So this is going to be 3, 4, 5. If you're worried about this, you know, the minus, make sure you actually expand that out. So this is minus 12 I2 plus 12 I1. Okay, just be careful with that. So that's going to be 3, 4, 5, 17 plus 4 more gives me 21. It's going to be 21 I1. And then the I2s, I got minus 12 and then minus another 4. So that gives me minus 16 I2 equals, the only number I have here is 10. 10 needs to move the other side, so it's minus 10. So that would be my first equation. Okay. KVL 2, as I go around, okay, I'm going to start here. I go into the minus of the 4 volt, so minus 4. Plus to minus, I go into the 2, and I2 follows convention, and I2 is the only current in that 2. I can then write, if I want, plus Vx, but it, you know, it's this, so it's going to be plus 4 times I2 minus I1. Get to the minus side of the 10, minus 10, and then as I come around, plus 2 times I2 is 0. Again, you want to get your like terms together. So I have a 4 and a 10 that I need to move to the other side, so this total is going to equal 14. I have 2I2, 6I2, 2 more makes 8I2, so I get 8I2, and then I have only a minus 4I1 right here. So this equation and this equation would be the 2 equations required to solve this problem. And again, you know, I'm doing this kind of fast, so just make sure you guys double check the numbers. I might have added wrong or something like that. All right. Problem 3. Problem 3, again, asks just to derive equations. So you want to make sure you only have the proper variables. So make sure only your node voltages are your variables. Starts off with a dependent source at the top valued at 3ix. And then this is node V2, this was node V1. There's a 3 ohm resistor, and that gets you to node V3. Below this, you have a 2, and then another 2. And below here is a 4. Below here is an 8 volt. And then a 4 amp. And their ground is given at the bottom. That's important because if they ask for node voltages, you have to get a reference. Okay. The only thing I need to know what Ix is so I can get rid of that variable. Ix is given as the current going this way. So the first thing I want to do, okay, is say, okay, the ground is at 0 volts. This is an 8 volt source. As source tells me that there's 8 more at the top than there is at the bottom. So if the bottom's at 0, the top has to be at 8. This is V1, but so is all of this. This is also V1. So I can write that Ix can be written as, the current's going this way, so I do plus to minus. The plus side is 8, the minus side is V1, and the resistance is 2. And so I would take that, stick it in here, and I would say, instead of calling this 3Ix, I would call this, 3Ix is actually equal to 3 over 2 times 8 minus V1. And I would just, that way, all of my equations only have V1, V2, and V3 as the variables. Okay? All right, so we start writing node equations. We can start with V1. Now you'll notice V1 and V2 are connected by a voltage source, and so there's going to be a supernode equation written there. So the first thing you can get, the first equation you can get from this is you know that the plus side, which is V2, minus the minus side, which is V1, has to be equal to 3Ix, which we said is equal to 3 over 2 times 8 minus V1. Okay, so that's equation 1. And again, you have to get these into proper form probably, just so they're easier to recognize. Then we have a second equation, which is going to be the supernode equation, which is the actual current equation for this. So if you look, this is all V1 here, right? So I get current going here, I get current going here, and then any current that goes through here turns into this current. And I didn't give that a number, that's a 3 ohm. So what you could say is KCL at the supernode is going to be this current down, right, which is minus 4, okay. This current to the right, which would be plus to minus V1 minus 8 over 2, and then any current that passes through here becomes this current, which has to be V2 minus V3 over 3. Equals 0. Finally, V3, you have current here, here, and here. And so KCL V3, I'm going to fit it here so it fits on the screen. KCL V3, you're looking from V3 to V2 through the 3 ohm. You're looking at V3 on this side to 8 through that 2 ohm, and then down you're going from V3 to the ground through the 4 is equal to 0. And so that would be your 1, 2, 3 equations. You just have to reorganize them into, this times V1, this times V2, this times V3 equals what. That way they're in the proper equation form. Even though technically the 3 I wrote are correct, you might, if you want to make sure you get credit and there's no problems because you don't know who's grading these things, make sure you try to write them like I did up here. Right? Organized it with whatever times I1, whatever times I2 equals whatever. That way you make sure it's easier for us to grade and you're more likely to get all your points. All right? Okay. Going smooth so far. Problem 4, the mesh problem. Okay. And here another dependent source, 3 times IO, we'll IO in a second, another current source here. So here we have a shared current source. Okay. This is given to be 6 amps, 2 ohms, 2 ohms, 3 ohms, 2 ohms. You're also given, that's my cat, if you can hear her. Vx is here. So you need to find I1, I2, and Vx. And IO is given as this current here. And you are given mesh directions. So this is I1, I2 going this way. One thing you should note is because of the current source here, this is going to have a mesh current of 6, okay, because it would be set by that. Alright, so the first thing you want to do, again, is try to get rid of this dependent variable. So I know that I0 is equal to, if you look here, I1 comes down, but I2 goes up. So I0 is going to be equal to I1 going with I0 minus I2, which is opposing it. That means that you can write 3I0 as being 3I1 minus 3I2. Right? That takes care of this dependent source right here. Other things we want to do, okay? One thing you should know is there's not you can't really super mesh this, okay? The reason you can't super mesh this is because if you did eliminate this to do super mesh, right, you would have to make a loop, but the loop would have to include this, something like that, and you can't do that either. So you don't really have an option to do super mesh on this, but you don't need one. Okay, you do have this shared source, okay, and you know that this is 6, this is 6, and this is I1, and so we can also write that I1 plus 6 is equal to 3I0, which is equal to 3I1 minus 3I2. Okay, so this is going to be your first equation that you can use. Your second equation is just KVL for I2, because I2 doesn't have any current sources, and so KVL for I2 will be plus to minus, plus to minus, plus to minus. It will be 2I2 plus 2I2 plus 6, because both I2 and the 6 are going the same way, they're both going that way, plus 2 times I2 is going up, I1 is coming down, and so that would be I2 minus I1 equals 0. That's equation 2. Okay, this is equation 2. Okay, but we have 3 variables, so we need a third equation. So where do we get our third equation if we can't super mesh across this this here? Okay, I don't know if you guys can see the pointer or not. So turns out if you look at what you have here, we know that I0 is this. We know that 3I0 is this, and so we know that this is true. Oh, okay, that's right. Sorry, got a little confused. You don't need a super mesh because the dependent source fills in the information you need. Because if you look between these two equations, I only have 2 unknowns. I didn't have 3 unknowns because this was given. Right, this third mesh was given as 3. So I believe you're all set here. If I double check, this equation only has I2, a number, I2, I1, and a number. This equation has I1, a number, I1, I2. So you do have 2 equations, 2 unknowns. So you can solve for I1 and I2. Now the question is, how do I find this Vx? To find this Vx, you do need to do a KVL. You need to find a KVL loop that has that in it. The easiest one to do is to just go all the way around the whole circuit. Because it doesn't have to be a proper mesh if you're just trying to find that voltage. So if you do KVL all the way around, okay, what you'll get is, I'm going to start here at the bottom and work my way around this way, minus Vx. Then I come to this resistor. The only current in this resistor is I2. I2 is defined going the other way, so this would be minus I2 times 2. And then I come all the way around to this resistor. The only current in this resistor is I1, so it's going to be minus 3 I1. and then that actually gets you all the way back around. So once you have this result, you can then solve for Vx by just including Vx in any of the loops. And you could have done it with, you know, any loop you want. You could have gone like this if you wanted. The only thing is you're not going to be able to include any path with this in it because you have no idea what this voltage is. Right? So it's either that or all the way around, I think, are the two options. All right. Problem 5. All right. Problem 5 asks you to use mesh to find Vx. Okay. All right, this is at 2 ohm at the top, 2 ohm in the middle. This is valued at 2 times Vx. So we'll have to substitute that out. We've got a 2 here, 8 volt in the middle, 2 on the bottom, and then a 2 amp current source, which just happens to have Vx across it. So I get 2Vx, I get this Vx. So I can't immediately eliminate that. Okay? So we'll just have to hang on to the fact that that's 2Vx for a little while. Okay? As you can see here, I can't write, you know, normally Vx is across a resistor, and I can write, you know, what Vx is in terms of the other currents, but there's no way to do it here. So we'll have to just save that for the end. Okay? All right. So this, I did this problem out last night. It was particularly... will give me a little bit of pause here on how you would do it, but essentially you're also given I1 is here, I2 is here, and I3 is here. Okay, so you do want to write some kind of super mesh to get rid of this section here, and so I know that 2Vx, which is the current going this direction, would be I3, because I3 goes in that direction, minus I1, because I1 comes back the other way. So now you can write that Vx is equal to 2 times, 1/2 I3 minus I1. Now you have Vx in terms of your variables. Also here, this 2 amp source is not shared by any other meshes. So I3, which goes this way, will be set by this. Now, unfortunately, the way I3 was given to you, it opposes this, so you have to make sure that you write that I3 is equal to negative 2 amps. That's your second equation. Okay. Now you can see that if you can find I1, you can solve this problem. You can write a KVL for I2. You cannot write a KVL for I1 because of the shared current source. So first we'll write the KVL for I2. Going around in this direction, plus minus, you get 2I2 plus another 2 times I2 is going the way I wrote plus minus this way. I1's coming back the other way, so it's going to be subtracted. Plus 8 is 0. Now, if I want, I can write the super mesh equation. Do I even need it? If you look at this, you get I2, I2, I1. So I need another equation with I1 and I2 in it. So yes, I do. I do need another mesh equation. The problem is, what did I write down? I did one at 8. Is it 1 including? Oh, okay. So I did do a super mesh, and the problem is you're going to look at it and you're going to say, why am I doing the super mesh? Because the point of the super mesh is to get around doing this, right? But now you have to include a path that looks like this. And you include this in it, and you're thinking, wait a minute, I can't write a mesh equation with that in it because I don't know what it is, but you do. So because this dependent source is dependent on this voltage, and it also dictates what the currents are, you can do a super mesh with Vx in it. So this problem's it's a little weird because of that. You know, normally you try to avoid having current sources in your meshes, but it's okay in this case. So as I go around, all right, let me do it here. I'm going like this. All right, and I can write plus the minus here. That's going to be, so KVL super mesh. It's going to be 2, I1 is the only current in there. I'm going to just write plus Vx for now, right? That's going to take me all the way to here. Here I have 2I3, come up through the 8, minus 8, go over through the 2, that's going to give me plus 2I1 minus I2 is equal to 0, okay? So now, Vx is equal to this. So I have this huge thing I can write. I got 2I1 plus 1/2 I3 minus I1 plus 2I3 plus 2I1 minus I2, and I move the 8 to the other side. I know all the I3s. And so, given that, I have one equation with just I1s and I2s, and a second equation with just I1s and I2s. That will allow you to solve for I1, I2, I3 is given, and then finally you can come back up here and say, all right, I finally know I1 and I3, and I can get my answer. So you guys could take a look at her results if you want to know what the actual number is, but yeah, that problem's a little bit tricky because you're trained, you know, not to do KVL with that source in it right here. You're trained to say no, you know, I don't want to do KVL here because of the source. But the only reason it works is because the Vx is controlled by this current source, so you can write it in terms of currents immediately, so it's okay. All right, so that's the end. That's 2B. If I can finish recording.